Okay, today we're going to cover section 7.3, adding and subtracting polynomial expressions. So first off, what is a monomial? A monomial in one variable is basically a product of a coefficient and a variable raised to some positive integer exponent. So what it looks like is it looks like some a to the x. This is what a monomial is going to look like, where a is our coefficient, x is the variable, could be any variable, and k is some degree of the monomial that's greater than 0. Okay. Then we have a binomial in one variable. Basically, it's going to be a sum or difference of two monomials. So we're going to take basically and add two of these together, or take one and subtract off the other. So that's going to be how a binomial works. Then a polynomial is basically going to be the sum or difference of a bunch of monomials, depending on how many you have. You can have, a trinomial would be 3, and then, further on, usually we just call them a polynomial. Now, the degree of a polynomial basically is the degree of the highest monomial. So if we do like what we show here, the standard form of a polynomial, we're going to write the polynomial in descending powers of the variables. So we have the highest variable first, then the next, then next, and next, until we get down to there's no variables. And so the degree of the polynomial is a degree of the highest one. So in this case, the degree of this polynomial is going to be 4. Okay, and so that's how you determine the degree of the polynomial, and the key is writing it in standard form and decreasing order of powers. Now what we can do is we can evaluate polynomials, and to evaluate polynomials, basically what we're going to do is we're going to start and be given some kind of a polynomial. Maybe we have, say, n squared plus 3n minus 11, and then they say where n is equal to, say, maybe a -6. All right, so what we're going to do is we're going to plug in -6 for n everywhere it is, and then solve. So -6 squared plus 3 times -6 minus 11. All right, so that's going to be, well, -6 squared, it's the whole thing is squared, so that's going to give us a positive 36. 3 times this -6 is going to be minus 18, and then minus 11. All right, so now we can do this several different ways. We can take 36 minus 18, and that's going to give us 18, and then we have minus 11, and that's equal to 6, or 7, sorry, write the wrong number down. Erase. All right, so now let's write the right 7 down here. And or we could take, the 18 plus the 11 and get a -29 and subtract that from 36 and get 7 as well. Either way, we get our answer is 7. Another one we could do, say we take n cubed minus 9 times n squared plus 23n minus 21, where let's say n is equal to 5. So now we're just going to plug in 5 everywhere there's an n. So we'll have 5 cubed minus 9 times 5 squared plus 23 times 5 minus 21. Okay. Well, first, if we take and do the 5 cubed, 5 times 5 is 25. Now, if we have 5 of those, that's equal to 125. Minus 9 times 25, so let's get rid of the squared first. And then plus, now 23 times 5, well, if we take that, 23 times 5, that's 15, that's 115. And so we have 115, and then we still have our minus 21. Now we also have to take 9 25s. Well, if we have 8 25s, that's 200, and one more is 225. So we have 125 minus 225 plus 115 minus 21. And now we kind of just add them all together. So if we take and add the positives together and we add the negatives together, what we're going to get is here that's going to be 240. And here that's going to be negative 246. Well, 240 minus 246 is a -6. Okay. So you could also do this if you wanted to with your calculator. Basically, you just take in 5 cubed minus 9 times 5 squared plus 23 times 5 minus 21, and you could get your answer that way. This is a way to kind of work down through it as you go without the calculator. All right. So the next thing we're going to do is we're going to look at adding and subtracting actual polynomial expressions. So really the key to doing this is we have to add like terms, and like terms mean same base and the same exponent. So if you have x squared and an x cubed, those are the same base, but the exponents are different. So we can't add those together. So it always has to have the same base and the same exponent to be like terms. So let's look at some examples here. Let's say we have 7m squared plus 5m cubed minus, and then 6m cubed minus 5m squared. All right, so let's do this first by getting rid of all the parentheses. So if we do the first one, we can just drop the parentheses, 7m squared plus 5m cubed. Now we have to distribute our negative here. So it's going to be a minus times this, so it's going to give us minus 6m cubed. And here we have a negative times a negative, that's positive, and so that's going to be 5m squared. All right, so we have an m squared here, and we have an m squared here. We have an m cubed here, and we have an m cubed here. So we can just add the coefficients and keep the variable part the same, and we should get our final polynomial added or subtracted, however you want to look at it, because part of it's adding, part of it's subtracting. So 7m squared plus 5m squared, that's going to give us 12m squared. And 5m cubed minus 6m cubed is going to be minus m cubed. Okay. And now at this point, we're done because we can't simplify any further. We have different terms, and so there's no more simplification on this example. All right, let's do another one. Let's say we have 3v to the fourth plus 1 plus 5 minus v to the fourth. Okay. So again, what I want to do is I want to drop all the parentheses and then kind of get all the like terms together. So if we do that, that's 3v to 1. Now this is plus, so we can just drop the parentheses here, and that would be what we have now. Now we're looking at the like terms. We have v to the fourth, v to the fourth. We have a number, and we have a number. So we have 3v to the fourth minus 1v to the fourth. That's going to give us 2v to the fourth. 1 plus 5 is 6. Okay? And so here, those are not like terms. So at that point, we're done adding those two expressions together. All right, let's do another one. Let's say we have, so what are we on? 3. So if we're on 3, so let's say we have 4n to the fourth plus 6 minus 4n minus 1 minus n to the fourth. Okay. So again, dropping the parentheses, looks like we're going to have to do a little distributing the negative sign on the second one. But the first one, there's nothing there. So we can just say, well, that's 4n to the fourth plus 6. Now, a minus times a 4n is going to be minus 4n. A minus times a minus 1 is going to be plus 1. And a minus times a minus n to the fourth is going to be plus n to the fourth. Now looking for like terms, well, we've got an n to the fourth and n to the fourth. Here we have a 6 and a 1, and then we just have an n, so it's all by itself. Now remember, if we want this in standard form, we want the highest degree first, so that's going to be the n to the fourth. So 4n to the fourth plus 1 n to the fourth is going to give us 5 n to the fourth. Then n's are next, so then minus 4n, because there's nothing else to add or subtract from it. And then 6 plus 1 is 7. And so that's going to be our expression when we get done adding this binomial and this trinomial together. All right, let's try another one. How about 6v plus 8v cubed plus 3 plus 4v cubed minus 3v. All right. So here it's all adding. So basically what we can do at this point is just drop our parentheses. So we have 6v plus 8v to the third plus 3 plus 4v to the third minus 3v. So looking for the highest power first, that looks like it's the 3. So we have one there. We will have one there. And then after that, it looks like we have v's. So that'll be our next term. And then after that, we just have a number. So we'll do it last. So we have 8v cubed minus or plus 4v cubed. So that's going to give us 11v cubed. Now 6 minus 3 is going to be plus 3v and then plus 3. And so that's going to be our final number where we, oh, wait a minute here. Did I take 8 and 4 and get that? That should be a 12. I don't know what I'm doing here. All right, so that's a 12, not an 11. So 8 plus 4, I must have been looking at the 3 next to it. So 8 plus 4 is 12, v cubed, and then plus the 6 minus 3 is 3, and then plus 3. All right, so that looks good. Okay, so let's do another one. Let's do one where we have a lot more terms we have to look at adding together. So that was 4, so let's do 5. So let's say here we do 7b to the third minus 4b plus 4b to the fourth minus, and now we have 8b to the third minus 4b squared plus 2b to the fourth minus 8b. All right. So the first one, we can just drop the parentheses because there's nothing in front there. So 7b to the third minus 4b plus 4b to the fourth. Now we're going to take the opposite of each one of these. So we're going to have to distribute that negative for each of our terms. So now that becomes minus 8b to the third. That becomes plus 4b squared. That becomes minus 2b to the fourth. And then that becomes plus 8b. All right. So now we look for highest terms. Well, it looks like the 4 has the highest term, and or the degree. Then we have the b cubed. We have another b cubed. And then we have the b squared. And then after that, we have just the b's. All right. So starting with this, we have 4 minus 2. Well, that's going to be a 2b to the fourth. Then we have a 7b cubed minus 8b cubed is going to be minus b cubed. Now our squared is, this looks to be the only one, so that's that one. So it's just going to be plus 4b squared. And then we have b, so we have minus 4 plus 8, so it's going to be plus 4b. All right, so that should be our answer. Let's maybe make that there be a little prettier so we can read it a little better so we don't think it's a number. And so, let's see, it's a B here. All right, so that would be our solution in standard form, decreasing powers of B and all the things added or subtracted together. All right, so that's our 5, so let's do 6. How about we do 3 things added together? Let's say we have 1 minus 3n to the fourth minus 8n cubed, and plus, and let's say we have 7n to the fourth minus, or actually plus here, sorry, plus 2 minus 6n squared plus 3n cubed. And then how about plus, let's say we have 4n cubed plus 8n to the fourth plus 7. All right, so we have these 3 polynomials we want to add together. Now, because they're separated by plus, basically what we can do is we can drop all of the parentheses and we don't have to worry about changing any signs. So let's go ahead and do that first. And so writing it down, hopefully writing all the right ones down. And plus 4n cubed plus 8n to the fourth plus 7. All right, so looking through here, we have n to the fourth as the highest degree. So we have n to the fourth here, n to the fourth here, and n to the fourth here. So we have 8 plus 7, so that's 15 minus 3. That's going to give, let's see, 8 and 7, 14, 15 minus 3 is going to give me 12n to the fourth. Okay. All right, so now what do we have? Now we have cubes. So we have 8n cubed, 3n cubed, and 4n, oh, just one of those, sorry, n cubed. I'll erase, there we go. So we have minus 8 and plus 3, so that's going to be minus 5. Plus 4 is going to be minus, so that's going to be minus n to the third. Okay. Now we have squareds. Well, it looks like we only have this one squared, so we can just write it down now. So it's a minus 6n squared. What about n's? I don't see any n's. And then all that's left is our single digits. 1 plus 2 is 3, plus 7 is 10, so plus 10. And that should then give us our final number. So 12n to the fourth minus n cubed minus 6n squared plus 10. All right. So that leads us into the end of the lecture. And now what I'll do is I'll go back and make another video with more examples.